Welcome to you guys. Welcome to my YouTube channel. Welcome to MATLAB. Okay, today we're going to talk about integration. So, generally, integration is the reverse of differentiation. To integrate means to increase a function with respect to a particular term. So, if you ask maybe, for example, to integrate a packet of biscuit, you just need to increase the quantity of the packet of biscuit. Okay, yeah. If you increase the packet number of biscuit in the packet, you have integrated the packet of biscuit. Okay, so the original form of the biscuit was maybe one packet, and once you integrate it becomes two or three. Okay, so now with that, let us now have a functional example. So for example, the integral of y with respect to x, that is dx, if y equals to 1 is x. What does this mean? It means that if you want to integrate a function y with respect to x, another function equals to a certain constant 1, the integral is simply x. So you just increase 1 to x to the function. Okay, now let us pass now to the basic rule of integration. So to integrate a function in terms of x, we must increase the power of x by 1, and we divide the integral by the new power of x plus a constant of integration. Do you get it? In other words, what I'm saying is the integral of x to the power n dx equals to x to the power n plus 1 all over n plus 1 minus all over x n plus 1 plus k. Okay, so I'm saying that the integral of a certain function x to the power n with respect to x, that is dx, equals to x to the power n plus 1 all over n plus 1, that is the but you increase the power by 1 and you divide now by the new power. So this plus a constant of integration k. Okay, so now with that, let us take some examples. Yeah, so let us find the integral of the following functions. Number 1, y equals to 3x. 2, y equals to 2x plus 1. 3, y equals to 3x squared. Okay, let us have the solutions. Okay, now simply for these integrals here, you are going to just apply the formula. Okay, so for number 1, the function y is 3x. So what do we get? We get that the integral of y dx equals to the integral of 3x dx. Now what does the law says? The law says that what? You increase the power by 1 and you divide by the new power. Okay, so now here the power of x is what? 1. So x is of degree 1. So you increase the power by 1, you're going to get 2. You divide now the function by the new power, you also have a 2. So and then you add the constant of integration k. Okay, so your integral will be 3 on 2 x squared plus k. Same for the second one. You just have to apply the rule infinitely and we get answers. Okay, it's very easy. So you integrate now y dx, that is the integral of 2x plus 1 dx, will be equal to, you increase the power of x by 1, you're going to get x squared divided by 2. But since there was another 2 in the function, we now divide the 2. Okay, and we're going to get 1. Now this one here, integrating this one with respect to x, we are just going to get x, okay, plus the constant k. So the final answer is x squared plus x plus k. So that is it. The third the material, people are going to do it as an exercise, okay, just to verify and see how it works. And you tell me your answers in the comment sections, please. I need your answer. If your answer is correct, I'm going to put a like on your comment. Okay. So let us now have integrals of the functions of the form y equals to ax plus b all that to the power n. How to integrate this type of functions? Okay, so we have also a general formula for this. The integral of y dx equals to the integral of what? Y, that is ax plus b all that to the power n dx, will simply be equals to what? Will simply be equals to the function. You increase the power of the function n plus 1, you divide by the new power, and you multiply the denominator by the differential of your function. Okay, the differential of what is inside. So as we have here ax plus b, if you differentiate it, you're going to get a. So you multiply now the denominator by a. So you multiply the denominator, you are in the denominator now, you are going to get a times the new power. And you then copy back your function, you multiply the 2 plus the new power, now n plus 1, and you add a constant of integration. So that is all for these particular forms. Okay, it's very easy. So let us have some example. Okay, so we are going to find the integral of 2x minus 1 all that cube dx. So just simply applying the formula, we are going to get that what? We are going to get that the integral of 2x minus 1 all that cube dx equals to 1 over 8 into 2x minus 1 to the power 4 plus k. Now what have happened here? I've increased the power of the function by 1, 4. I've also differentiated the function here, 2x, and I've gotten 2. Okay, so now when you have that, now you multiply the 2 in the denominator. Okay, so the 2 will fall in the denominator, like just like in the formula. Okay, so if the formula is you can just take a paper and copy the formula. You'll be applying it. Okay, it will help you. Okay, so you're going to get this 1 over 8 into 2x minus 1 all that to the power 4 plus k. Now let us pass to the next part. Okay, so for this one here, we are going to see some laws of integration of polynomials. Okay, so the first one is the integral of a function, that is the integral of f of x plus or minus g of x dx, equals to what? The integral of f of x dx plus or minus the integral of g of x. That is, in other words, if you have a function plus another function, all with respect to the same particular term, you can split it into two different equations. Okay, that is, you can split the first function, you integrate it on its own, and you integrate this other one on its own. So for example, the integral of 2x minus 1 dx, we can split this one into two. We are going to get the integral of 2x dx minus the integral of dx. Integrating both of them, you are going to get what? X squared minus x plus k. So that is it. Now the second law is the integral of f prime of x all over f of x dx equals to ln of f of x plus k. Okay, now for example, the integral of 1 all over x, where 1 here is f prime of x, because when you differentiate x, you're going to get 1. So the integral of 1 all over x dx equals to ln of x plus k. Straightforward. Okay, so for this law to be applied correctly, you just need to verify if the numerator is the differential of the denominator. Okay, so we get that. Now the next law, we have that the integral of 1 all over the square root of 1 minus x squared dx equals to sine inverse of x plus k. Okay, we have that. The other law says the integral of negative 1 all over the square root of 1 minus x squared dx equals to cos inverse of x plus k. Another one says the integral of 1 all over 1 plus x squared dx equals to tan inverse of x plus k. So all these particular forms, these particular fixed forms, you are going to just be taking examples in solving, and you are going to see how we apply them. Okay, yeah, I'm going to see it. So now let us take some other laws, but for trigonometric functions now. Okay, now in trigonometry we have what? The integral of cos x dx equals to sine x plus k. The second one says the integral of sine x dx equals to negative cos x plus k. The third one says the integral of cos ax dx equals to 1 all over a sine ax plus k. The other one says the integral of sec squared x dx equals to tan x plus k. And the other one is the integral of sine ax dx equals to negative 1 all over a cos ax plus 1. Okay, yeah, the integral of sine ax dx equals to negative 1 all over a cos ax plus k. And finally, we have again that the integral of sec squared of ax plus b dx equals to 1 all over a tan ax plus b plus k. So for all these particular trigonometric functions, you are going to analyze one day, and we discover that all these integrals, okay, have is all the different answers are the differentials of our function. Okay, just to verify, let us differentiate sine x. If you differentiate sine x, you're going to get what? Cos x. You see? Now, if you differentiate cos x, you're going to get what? Negative sine x. To get back this function, we now have to add this negative sign. So in trigonometry, it's very particular, it's very fixed. Just like if you differentiate tan x, you're going to get what? Sec squared x. So that's another way of verifying that your integral is correct if you know how to differentiate also. Yeah. So with that said, let us now pass to the different substitution techniques. Okay. So we have the U substitution method, the T substitution method, and the trigonometric substitution method. So these are the three basic methods that we use in all different type of integrals, and we work with them. So for today, let us start first with the U substitution method. Okay. So let us evaluate this. The integral of 1 all over the square root of 9 minus x squared dx. Okay. So solving that, we first of all start by simplifying the integral. That is one of the key things in integration. Once you see an integral which seems to be complex, start by breaking it down to see if there's another way of having it. So the integral of 1 all over the square root of 9 minus x squared dx will be equal to what? The integral of 1 all over, you factor out 9 here, you're going to get what? 9 into 1 minus x squared over 9 dx. Okay, I'm just simplifying, I've not started integrating. So this will be equal to the integral of what? Use the square root of 9, you're going to get this into 1 minus x all over 3 all that squared. Okay, that is 3 to the power 2 is 9. So that's why I've just put it in this form to, so it's, you have applied indices here. Okay, so that's law of indices. So now with that again, we have what? This one will be equals to 1 all over 3, because we'll factor out 1 over 3 now, because these are constants, so we don't really need to integrate them, we just integrate the functions. Okay, so it will be equal to 1 over 3, the integral of 1 all over 1 minus x all over 3 all that square. So now let us start now substituting. So now we let our u to be equals to something like, to be equals to x on 3. Okay, that particular function for us to integrate easily. So if you have this, you first of all have to differentiate u. If you differentiate u, you are going to get what? 1 all over 3. Now this will imply that what? You make now dx the subject in this equation, and you're going to get dx to be equals to 3 du. Because here we're talking about a substitution method, so all will be now in terms of u. Okay, so now with that, we replace all our new terms in our integral. So the integral of 1 all over the square root of 9 minus x squared dx will be equals to 1 all over 3, the integral of 1 all over the square root of 1 minus u squared times 3 du. Dx equals to 3 du. Okay, you just replace it there, and you now start integrating. So now you get what? The integral of 1 all over the square root of 1 minus u squared du. The 3 was factored out and cancelled the other 3. You get this. So this one will be equals to what? Sine inverse of u plus k. And this sine inverse of u is a particular form that we have seen behind a particular law. So we take it like that. So once we simplify this other equation here, this function here, you see how once you finish simplifying, it become very easy to integrate. So the integral will simply be sine inverse of u plus k. But now the value of u was what? X over 3. So at the end, you can now replace back your u. Okay, you can replace back your x over 3, and you get that as the integral. So that is all for the video. Okay, so please, I thank you guys for watching. You're going to see the other part, that is the T substitution method and the trigonometric substitution method, in other videos. Okay, so please like, comment, and share, and don't forget to subscribe to my YouTube channel. It's such a way that you should be among the first to be notified about the video that I will post for integration. So see you guys in the other video. Thank you.